what's their exam؟ شو الامتحان؟ signals on systems ولا DSP and you don't have? Good for you. طيب questions from last time? No? So last time we stopped where? Here. Yep. So we saw this duplexing. Okay, we said this FDD is not FDMA. FDMA is to have multiple users to access. Okay, FDD is to differentiate between uplink and downlink for the same user. Right? So the same user wants to access, he wants to upload or download. Okay, then we need to distinguish between the upload and download. How to distinguish? Through FDD. If FDD, then over frequency. Then here, one frequency for the uplink, one frequency for the downlink. So here, this is the uplink frequencies, downlink frequencies, and then here we have this one for uplink, or this one for downlink. Good. We said that this has an advantage that there is no need for synchronize. You upload, then you download, then you upload, then you upload, and so on. Easiest example is web browsing. So you press on a website, it downloads, then you read, you do nothing, then you press, then it's a request, you upload, and so on. We commented about the unidirectional communication. I see here. What is this? We started TDD then. Okay, and we finished FDD. We commented on all the properties of FDD. Okay, and here we commented about what happens whenever you have, because in uplink and downlink you have two different frequencies, so you have two different channels. Today, in the female, they asked me why you have two different channels, why the channel is different whenever you change the frequency. It was a valid question. Okay, I thought it was known, but I based on that, I will explain it here also. Okay. We said that the channel is like this. So here, if this is time or frequency, and here this is the amount of received power, the channel is like this. We could have good performance, or we could have bad performance, right? Why it is good or bad? Because always we have noise in the channel, in the system, sorry. Okay, that adds on. And it is like this, for example. So whenever we have then this case, we have the received signal will be with the same level as noise. Okay, then the performance will be bad, or here it is less than the noise. Whenever you receive it here, it is higher than the noise, then you can decode without problems. This is it's an example. Okay, we have systems now that the amount of received power is much less than the noise, but even with that we can still recover the signal. But yeah, as an example. Okay, so we could have good or bad. What does it mean, good or bad? Okay. So the question is, why it has this shape? Okay, why the shape of the wireless channel is like this? Good. If we look to it in time or on the frequency, the same. Okay, so starting with the time. Actually, it is the same shape. Okay, so here in time, it is like this, and it is changing. So here, this is the transmitter, this is the receiver, or the Ooredoo tower is the receiver. We measure the signal from here to here, and it is showing this shape. Good, changing over the time. No one moving. Okay, no students in the class, but the channel will change. So what is changing if there is nobody moving? So here, this is the signal. Okay, imagine I go to the lab. This is transmitter, this is receiver. Okay, we put a fixed signal to be sent once all the time. Okay, and then nobody is moving. We put an oscilloscope. We measure what's happening with the channel. Okay, and we see it is like this. Why? Who's moving? No one is moving. So why the channel is doing this? The medium is changing. How? Exactly. Perfect answer. Okay. So we have the air particles. So whenever our signal will move from here to there, definitely we don't have Superman eyes to see what's happening here in the middle, but we have here million of particles or atoms or electrons and so on that they are moving. They are moving randomly. 1 million atoms of nitrogen or 200,000 of oxygen or blah 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 oxygen or CO2, whatever we have here, and they are moving randomly and at high speeds, but we don't see them. Good. This is the reason why we have the channel like this. Good. So this behavior, and it is something that we can never control. We can never control how the atoms will move. They move randomly. This is why the channel will look like this. It has this shape. Good. So again, this shape is not because you are moving, and people think that, well, yeah, whenever you move, yeah, you will make it worse. Okay, but by itself is bad. So the channel, the wireless channel by itself is bad. Good. Okay. One more thing. Okay, let me remind you about circuits one. You remember here source, destination, or in the system. Here, whenever this is transmitting to this one, what this one is receiving is receiving power. Good. So wherever it receives power, the power is larger than the noise, is good, less than the noise, bad, and so on. Okay. Do you remember from circuits one, how can you guarantee the maximum power here? Yes, and that was called the maximum power transfer, right? So the idea, it was here, we want maximum power to be here. Good. Okay. Back to our example, whenever I have my phone transmitting to there, who is the source? The phone. So here, the phone is the source. Who is the load? The router or the receiver. And what is R? This is the medium. Good. So the medium, which is this wireless channel, is a good conductor or a bad conductor? One. The noise is because of the electronics, not because of the channel. But yeah, this medium is a good conductor or bad conductor? Whenever you learned even high school, water, wood, whatever. So here, the airspace is a good medium or bad medium? Conductor or non-conductor? It's good. Okay. If it is good, then here we have a socket with electricity. Do you get electrified? Do you? Why? Because it is not a conductor. So the wireless channel, wireless medium, it is a bad conductor, really bad. So here, wireless link is a bad conductor. Otherwise, we will all get electrified from all of these sockets. Good. So if it is bad conductor, why do you use it? Even everywhere. Okay, good. So because we need to move, because we need to move, we are forced to use it. Even it is bad, but لا حول ولا قوة. There is no other solution. This is why we always say that the wire line is much better than the wireless in terms of performance and everything. So the wire line, whenever you have wireline link, the wireline link, it's like this. Why? It is copper with whatever concentration of the copper. So but you have everything known. You put electricity on it, the electrons will move perfectly without any issues. So the channel will be like this. And this is why here in this course we study wireless, because if we solve the issues of wireless, by default we solve them for wireline. Wireline is a trivial one, easy compared to the wireless. Yani we are giving a headache to ourselves, but why we are doing that? Because we need to move, to move without wires. This is why the wireless thing is a bad, but we have to deal with it. And again, the link itself It's something that we do not control. It is like this. Clear? Clear to all? This is whenever it changes over the time. Why it changes over frequency? Because if we do it like this is the frequency. So, and here the received power. The channel also on frequency is doing this. Why? On the same time. So if we freeze the time, okay, over two different frequencies, okay, it is doing like this. Why do you think that is happening? Circuits 2. You all finished circuits 2, right? In circuits 2, it was a bit different. So here, instead of R, it was called X, I think, right? Instead of resistance, impedance. Z ولا X؟ Z؟ طيب يلا Z. ZL وهي Z وهي VS AC signal or time variable. Good. So here, this Z, what is it based on? R plus J omega L plus 1 over J omega C. Do you remember the stuff? What is the omega, ya Muhammad Noor? 2 pi F. So the F is here. Okay. Then here, by changing the value of the frequency, you are changing the value of the impedance. If you are changing the value of the impedance, you are changing the matching between the impedance of the transmission line with the impedance of the load. By changing this value, the amount of power that is received is different. This is the reason. Clear? So here, the channel, why it has this shape with respect to the frequency, this is the motivation. Good so far? Clear to all? Good. So based on that, we were saying that you could have a channel that is good in the uplink or bad on the downlink. You cannot control. So here, maybe this would happen. What will happen if you are given a good channel on the uplink or bad channel on the downlink? You will talk, but you cannot hear. And what will happen eventually? You will drop the call. The call is useless. The other guy will say, hello, hello, you don't hear anything. You disconnect. And you call again. So here, this issue is challenging because here you have a channel, different channel, and the system has to deal with two different channels that they are not related. Good? Clear? Why they are not related? Why here their performance is different? This is at one frequency, let's say F1, and this is at another frequency, F2. Cool? Questions? No? Okay. So this was the disadvantages for the FDD. Let's go to TDD. So TDD, well, FDD is 1G, 2G, 3G, 4G, even 5G. So in 5G, they give them the freedom. So the operator for 5G, it can deploy FDD or TDD. Both options are available in the standard. But yeah, TDD was new in 5G. It was not in the previous Gs. What is the idea of the TDD? Oh, when I see that here, we talked about the delay. So here the communication is discontinuous. So it is for the same frequency. On the same frequency, you are doing uplink, then downlink, then uplink, then downlink. So your phone is connecting, disconnecting, receiving, transmitting, receiving, transmitting, receiving, transmitting. Okay. So here, because it is the same frequency, then it is the same channel. So here you have the same channel. The major advantage, and here this is an advantage. But yeah, this is why they are thinking about TDD in 5G. This is the major advantage. This is what is really good. The ratio uplink downlink. What is the ratio uplink downlink? Yeah, it is here. So in 2G, I told you that the ratio is 50-50. 50% for uplink, 50% for downlink. Why? Because the system is designed to make phone calls. So you hear, you talk. Then in 3G, the cut was 2080. In 4G, it was 3070. But yeah, here it is a value That has to be decided. So operator Ooredoo, they said has to be 3070. End of the story. They cannot change it. If they want to change it, they have to shut down the whole system and restart it. Okay? It is a very challenging operation. Okay. Whenever it is 3070, okay, imagine the system put it at 3070. You are downloading all the time. What you will do with the 30? Nothing. It's a waste for you. You don't need to upload, but yeah, the system has forced you to make it 3070, and you need to download all the time. So the system is not efficient. In TDD, they said, okay, how we can solve this problem? They said, okay, if we make it uplink, downlink, I can make it dynamic. So, where I can explain it here. Imagine these are the time slots. On the first time slot, I am making a voice call, 50 for uplink, 50 for downlink. On the second time slot, I am downloading, I don't want the uplink. I can make it 100% for downlink. On the third one, I am uploading a Snapchat picture, okay, photo, while I'm receiving an email on my email account that is on the phone. Then I will make it 37%, and here 63%. Any ratio can be done based on what? Based on what are the applications that you are using. So this system will, you will use all the resources. You will not say, "Wallah, hadi uplink or downlink." Okay, you will say, "What do I need?" So the phone will calculate, okay, what is needed, what are the running applications, and it will communicate to the base station, tower, or router. Okay, I need this. Okay, now don't tell me upload, download. Now I need to download all the time. I'm downloading a movie. Okay, so I don't need to upload anything. Just send me download. Okay, so here, then you will take all the time to download at here. Then what is the conclusion? This system is much more efficient. So the efficiency, the performance, which means data rate, everything is much better. Clear? Good. Challenge for the system. So definitely there is a 5G chip here, so it has to be there. Okay? But yeah, so the first issue is that because of this, so here you need to know exactly when this will be uplink, when this will be downlink. Because on the other system, you know, it is 30%, 70%. You forget about it, okay? But here it is all the time changing. When there is no uplink, only downlink. When uplink, when downlink. So here the synchronization has to be really tough. Okay? It has to be really good in terms of the synchronization in order to make it perfect. Okay? This is why here the disadvantage, first disadvantage is that it needs for strict synchronization. Cool. The second one, you have to be aware of the interference. Why? Because maybe you want to upload or download at the same time. Okay, so others maybe they're uploading, downloading not at the same time as you, so you receive some interference. But even of that, it is solvable. But yeah, here this is another disadvantage. Good. Based on that, which system do you like more, TDD or FDD? Why? So better for the user. If the user is dynamic, then this is okay. So whenever now they would like to set up the system, they have to think. Are even they can put some TDDs in some places, some FDDs in others. Okay. So let's put scenarios. For example, where do you wanted to put it? Daphne area, for example. Okay. And during the day, can you predict what the people will do? How? But can you make a good estimation of, yeah, I know that the people in Dafna, they are people working on the business, so what do? They will be downloading movies? I don't think so. They will be making phone calls, most probably, and they will be receiving so many emails, most probably. So based on that, you make your calculation. You can make a cut. You can say, based on the usage of the people here, then I will do it 32.5, 67.5. Good. While in other places, you cannot make a prediction. Example, mall, for example. In a mall, there are people making phone calls. Some ladies, well, they are also guys, okay? Look to this picture, okay? Look to that, okay? What do you think about this? What do you think about so, uploading all the time? Some others, or at least myself, I'm waiting for my wife. I'm bored, so I download a movie. Okay. My kid is with me. He is bored. Okay, maybe he will check his account on Instagram. Okay, so which means that the classes of people is huge. Okay, some people working there, they are bored. Maybe in their shop no one is entering. Okay, so they will start a TikTok. Some others, they are busy on their shop. They cannot even check the phone. Okay, so the usage inside the mall is what we call heterogeneous. Okay, so it is from every kind. So you cannot make an easy prediction. Then in that scenario, it is much better to use TDD. Is it clear? So if you can predict on average, you cannot make for each one of the users, but on average, you can make a good prediction, okay, of what will be the usage in that cell. The FGD maybe is better. Okay, it is low complexity, no synchronization, things are good. But you need it to be more efficient because the users that you have in your system are kind of mixed up. Salata. Okay, so in that case, you have to go to TDD. Okay, even if it's more complex, but it can deal with such scenario that it is completely everyone asking for a different application. Clear? So TDD not better than FDD, FDD not better than TDD. You have to first check for the scenario. For scenario A, FDD is better. For scenario B, TDD is better. And you as an engineer, you are the one who will decide. Clear? Questions? Okay. So now we are done with FTD and DDD. Let's see how we can get high data rate. So here it says that we always need in the wireless to have a large data rate so that every application that we have, it works without any issue. The objective is always to make wireless to be equal or better than wireline. Currently, wireless is better than wireline. Why? Example, how much is the wireline that you have at home? The data rate? There is a 200? Mm? No, I was asking. You have Ooredoo at home or Vodafone? Vodafone. Oh, I'm not aware of the Vodafone rates. But yeah, Ooredoo, for example, they give you 150 megabit per second, 300 megabit per second, okay? 1,000, okay? And so on. So here, this is the in terms of the depends on how much you are going to pay. Okay? The wireless, how much is the data rate on wireless? On cellular, whenever you connect cellular with your phone. 100, يعني this is يعني you are lucky to get the 100, okay? Usually 20, 25, 40, but some areas, yeah, you can reach 60 or 70, but this is the first point. Second point, it is not guaranteed. So you can be connected on the phone on 5G, then on H, then on E, then on 4G. So which means that the speed, the data rate is variable. Okay? This is why wireless will be always less than wireline. Well, unless there is no wireline. Okay, there are countries surrounding even countries. Well, so many countries in the world they don't have fiber. So if they don't have fiber, their wireline connection is very bad. Good. I always say that whenever you are staying on the same spot, okay, not moving, connect a wire. Your data rate will be much better. The system, the service is with the same pace, no delay, everything is good. When you have to go to wireless, when you move again, you need to move. لا حول ولا قوة. You have to deal with all the challenges of wireless. Good. Let's see here, as I said, okay, the course is more focused on wireless because it is the more challenging. If you do it for wireless, for wireline, it is a piece of cake. Good. First equation in this chapter. Data rate, so this is the one that is measured in megabit per second, or kilobit per second, and so on, equals to bandwidth, which is measured in hertz, log to 1 plus the transmit power, the one that measured in watts, multiplying by the SNR. You know what is the SNR, right? Signal to noise ratio. You have seen it in signal systems. Good. So looking to this equation, from a mathematical point of view, let's start. Imagine you are not engineers, pure math, okay, students. What is better to increase? Bandwidth, power, or received quality, this SNR, to increase the rate? Why?
Because if with the log, we increase as much as we increase the log, it will not.
Perfect. So why the log functions like this? Okay, so you might increase, but the increase here it is low. So I can imagine I have 1 unit. So here, if I increase the SNR by 1, the data rate will increase by 0.3, 0.4. If I increase the power by 1, 0.2, 0.3, depending on what is the ratio. You increase the bandwidth by 1, the data rate increase by 1. You increase the bandwidth by 2, data rate by 2. Increase the bandwidth by 1 million, the data rate will increase by 1 million. Why? The relation is linear. This is equal to this, multiplying whatever. Good. But here, whenever you increase the power, depending on are you here or here or here, you increase by 1, maybe the data rate will increase by 0.1. Whenever you are lucky, by 0.8. Good. So from a math point of view, it is much better to increase the bandwidth. Do you agree? Okay. Let's see now from an engineering point of view. So from engineering point of view, to increase the bandwidth is good or bad, and why? First of all, to increase the bandwidth, where you can get the bandwidth from? You have to buy it, rent it. From where? Sorry? Okay, we said here the name last round. You remember? You have to go to CRA, okay, and to say we need more bandwidth. Problems. First one, maybe simply it is not available. Oh, sorry, we don't have any bandwidth available. Come next year, maybe we will have. Okay, come in 6 months, and so on. Second problem, very expensive. Okay, the 1 megahertz costs millions of reals. 1 mega, millions. So would you use this option? Power. To increase the power, where you will get the power to increase it? From where? From battery. So here, I want to increase the transmit power from mobile phone. I will take it from the battery. So first issue. So here, whenever you increase the power, what will happen to the battery? So battery life will decrease. If it is a router here, there is no battery. Where the power will come from? Which so but that's it. So here, or you increase the electricity bill. Qatar University pays millions per month on the electricity bill. Yeah, obviously this, but also that. So here, so the electricity bill will increase. So this is the first issue with the power. Second issue with the power. Whenever you increase the power, do you know about more disadvantages? Heat. It will generate heat. On the mobile phone, what the heat will do? it will not reach to damage, but yani, I don't know if it happened to you, but if you heavily use the phone to download a video or whatever, and its heat is going up, the phone will turn off. Why it is turning off? For safety, because otherwise the components will damage. So here, why? Because of the heat. طيب laptop, whenever the heat is increased on the laptop, the fan, okay, well, the fan will consume power. Well, same story. So here, heat is an issue with the power. Third issue with the power, increasing the power. But you can say bad stuff about increasing the power.
Maybe more interference between the components. Because the power to transfer is become larger, so more interference or something.
How is that more interference? Good. Imagine that I am talking to Muhammad Noor, or Yusuf is talking to Amir. If we talk silently, okay, then we will hear each other. If I start shouting, you will not hear anymore. So what you will do? You will start shouting. So if I start shouting so that Muhammad Noor will hear me, then Yusuf will start shouting so Amir will hear him. Or Saeed will start shouting so Asad will hear him. Okay, so what will happen? Whenever we increase the power, we increase the interference to all, and everyone will start interfering more. Okay, reaching to the point that when we call the system in that case to be interference controlled system. So here we will have interference controlled system. It's like the system will break down. Okay, every phone will start increasing transmit power so that signal is received because of the interference from others. Okay, we will have an issue. This is actually why the standards are all the time decreasing the amount of transmit power. So always they want to decrease the amount of transmit power because to avoid interference controlled scenarios. Okay. Fourth issue, clear, but good point, yeah, Yusuf. Fourth issue with the power, increasing the power. That's it. Health problems. Why? Last time I told you what happens whenever with the power that goes out from the phone, whenever you make a phone call, half of it will it's absorbed by your body. Okay, so more power that is absorbed by your body. We don't know when it will become harmful, but we know that it is heating up your brain. Good. So all of this because of the power. Then you will increase the power to increase the data rate. Good. SNR. So here, first component, second component, third component. First of all, SNR is the signal to power ratio. Its equation is like this. Signal desired signal power over the noise power. By the way, what is the unit for this SNR? Why? That's it. It's power over power. This is why here unit less. Even sometimes whenever you see it in dB, dB is not a unit. dB is just a scale. So dB is not a unit. So this is always unitless. Okay. For this SNR then, how to increase it? We have two ways. First one, even we decrease the noise power or we increase the desired signal power. Do you agree? Just looking to the equation. Let's go with the or and يعني if you can do both of them much better. Noise power equals to from signal and systems. What is the noise power equals to? What the noise depends on? Do you remember, Amir?
I think it was step size over 12.
Sorry? Again?
I'm not sure. I think it was step size over 12 was step size squared over 12.
I don't know. No. Noise power. Do you remember what is the noise power? No. Just a minute. I have Muhammad, your name? Ahmed Al-Ashqar. وهناك. Okay. Okay. Amir here, right? So all of these are out. Amir, هيو Amir. وthen Muhammad Yusuf. Good. The noise power, it has an equation. The equation stands like this. K, T, B, or BW. What is it's a product. What is the K? K is a constant called Boltzmann constant. You remember it? Do you? You have seen it or not?
Yes.
So yeah, so Boltzmann constant. 1.2 10 to the minus whatever. Okay, it's a constant. I don't know. Okay, T, temperature. And it is temperature in kelvins even. Okay, BW, bandwidth. So the noise power is a constant multiplying by the temperature multiplying by the bandwidth. How to make it smaller? Here we said that we want to decrease the noise power. So how to decrease it? Decrease it. The constant, can you decrease the constant? No, it's constant. It's untouchable, okay? The temperature, can you decrease the temperature? How? In the fridge. And whenever you want to call, to put in the fridge, okay? Or this phone can be only used in Norway. That will work? That will not work. Okay? So the temperature is a parameter that is based on where is the customer. Okay, yeah, obviously we don't assume that he is in a foundry, okay, and the temperature is 80, but yeah, regular temperatures, okay, up to 60, the phone should work perfectly. Okay, so here temperature, and again it is in Kelvin, so you can never reach zero. Okay, so the temperature is something that is not a design parameter. But can you tell me that, okay, well, I sell you this phone, but this phone, يعني be careful. يعني هو حساس, okay? It needs all the time to be in a cool area. You cannot take it outside. On the phone? You already have a fan on the phone. Do you have? My phone has a fan. Do your phone? No phones have a fan. Do you imagine a phone with the fan? Not logical. Okay, so here, fan is not possible. So to deal with the temperature again is not a design parameter. It's a parameter that is given. Okay, where is the customer? Okay. BW, to decrease the BW, is it possible? Yes, but again, if you decrease the bandwidth, you decrease the data rate, which is your objective. So you see here, your objective is to increase the data rate. If you need to increase it, you have to increase the SNR. If you want to increase the SNR, you have to decrease the noise. If you decrease the noise, you have to decrease the bandwidth, which will decrease the data rate. So you did nothing. Okay. So here, to deal with the bandwidth, actually the bandwidth here is somehow tricky because it is here, and it is internally here. Good. So to decrease the noise power is simply impossible. What is the other option? To increase the desired signal power. How to do that? The signal power, definitely. You cannot increase. So here, whenever I say we need to increase the desired signal power, so this is the transmitter. This is the receiver. Here I'm transmitting 1 watt. Instead of 0.1 watts, I want to make them 0.3 watts received. Here I don't want to increase. If I increase this one, I'm coming back to the power issue. So with the same amount of transmitted power, how can I make the receiver to receive more? This is the idea. So let me repeat. Here the transmitter power is fixed. So here I want the received power, okay, to be more. Okay. So I want, if it is now receiving 0.1 watt out of the 1 watt, I want them to be 0.4, 0.3, and so on. Okay, without touching this one. If I touch this one, this is this parameter, the transmit power. Good. Maybe it's good here to add. Even I'm saying it, but to write it, transmit power, and here desired received signal power. Good. How to make this? Yalla, tell me how.
I think you said before the resistance. So
the resistance, yeah, you want to match it to the channel, okay? Good point, but how to match it to the channel? So you have to measure all the time the channel. Yeah, good. You come close, okay? But yeah, here conclusion, and actually this is what we will see on the remaining of the course. To do this is not easy, complex. Solutions. So instead of using one antenna, I can use the 2 antennas to receive my signal. Okay. So hey, you receiver, you receive my received signal from my phone, not only with 1 antenna, with 2 antennas. Yes, it can do it. Okay. And with this way, it will increase from 0.1 watt to 0.15, 0.16. We could have a gain of 50 to 60%. Okay, but I'm losing 1 antenna. Okay, these antennas, they are made for 1. So instead of here 4, so instead of Amir Muhammad Yusuf to use 1 each. If we want to increase the signal received by Amir, we have to take 2 antennas. So one of you will remain with no antenna. Good. So here, yeah, it is complex, and we have to see how. There are other ways to do it. Multiple antenna is one of them. We will see something to do with the modulation. Yeah, so we have ways, but in general, it is complex. What can you conclude then? We need more data rate. Always we need more data rate. People are not satisfied never with data rate. How? Tell me. Yeah, we said about the 3 parameters. What would you suggest?
until you get the best result.
But you cannot increase the power, transmit power. This is complex to do. This is expensive to do. What to do? It's complex. So if you do the complex, then your mobile phones need to be more complex, so they will be more expensive. So maybe your customers will not buy them anymore. Imagine you are a decision maker inside Ooredoo. What to do? But first of all, my question is clear. Muhammad Noor. Yeah, let's think together. What would you do? You will increase the power والله يرد الناس اللي معه cancer واللي whatever happens we will do it. Why? No, they don't care about health. They don't do it because of the interference, as your colleague said. Okay, so from engineering point of view, because of this and this. Okay, with the battery, even with the battery, we can deal. Okay, we every time they're improving the battery and so on, but the heat is killing the system. Okay, and the interference. So increasing the power, not an option. To improve the SNR, they need to go, they need time to deploy complex schemes. Again, they will make the phones to be complex and so on. So, but yeah, they are doing, but it is not improving that fast. Then what remains?
The rate.
Yeah, to increase the rate, what remains? The bandwidth, because we said it is expensive. That's it. They really don't care. Why they don't care if it is expensive? That's it. So it is expensive. Already it's buying it expensive. It will make the service to be expensive. So who will finally pay? Us, the customers. So here, this is why the first solution is to increase the bandwidth. So operators, plan A or plan B or plan C for them is we need more bandwidth. Okay, so the operators are talking to CRA every day. We need more bandwidth. دبرونا bandwidth. We need bandwidth. من وين في bandwidth? We need bandwidth. يعني هيك شوية bandwidth here and there. Find some bandwidth. Okay. So the way or the problem of finding bandwidth, it is a worldwide problem. Okay. How to find bandwidth. Okay. You also did here EM? No? Maybe I have still the slides for EM. EM, chapter 1. Chapter 1. This is actually what CRA they have, okay? So this is the frequency allocation in the US, but here in Qatar we have a copy-paste one. Okay, so this is the frequency allocation that we have here. Do you see any gap? Zero gaps. Okay, the system is overcrowded. Okay, with so many applications running at the same time. Okay, so where is 2G, for example? 2G is 300, 900. Yeah, okay, good. So here it seems that I put it for the students. Okay, so here this system is the uplink or downlink for GSM most probably. You see this small one compared to all the others. Okay, so to find bandwidth, it is a challenge, real challenge. Okay, solution. The only solution that it came to their mind is, wow, time is flying. Okay, so the only solution that it came to their mind is, okay, so all the band, as I show you now, is extremely crowded. Move to higher bands. Okay, so here move to higher bands. Okay, I will put it here, millimeter wave and terahertz. Next time I will comment on this stuff. Today we will stop. Okay, yeah, we will stop. Okay, many of your colleagues are not here, so I will decrease the amount of material. Questions? Sure? No issues? So see you on Monday, inshallah.